All right, thank you for joining us. We're here today to talk about what we believe is the single biggest investment theme for the next several years. We're seeing an explosive, multi-year supercycle in AI memory, and frankly, it's creating a generational opportunity for investors. Let's get right into it. So let's just put a number on this right away to frame the conversation. 130%. That's the projected year-over-year growth in demand for what's called high bandwidth memory, or HBM, for 2025 alone. This isn't some gradual trend. This is a tidal wave of demand that's building right now. So here's how we're going to break this down. First, we'll lay out the core supercycle thesis. Then we need to understand what's driving all this demand, a process called inference. From there, we'll look at the supply bottleneck, the memory wall. And finally, we'll get to the actionable ideas, how to invest directly in the memory makers, and how to play it using a picks and shovel strategy. Okay, so first up, the AI memory supercycle. Let's really dig into the foundational argument for why we are so incredibly focused on this one specific sector. Here is the bottom line, the crucial point we want you to take away today. The ultimate performance of any AI system, it is fundamentally determined by its memory. So this absolutely insatiable demand for more and more powerful AI is creating a structural shortage, and that's leading to soaring prices and, frankly, lavish profits for a very, very select group of companies that control the supply. Now, to really grasp the scale of this opportunity, you have to understand what's lighting the fire under this demand. And it's a major shift in the AI workload, away from training models to something called inference. This is the why behind the whole thesis. You see, for years, all the buzz has been about training these huge AI models, right? Which is very compute heavy. But now the primary job is shifting to actually using these models, asking them questions, getting answers. That process is inference, and it has completely different and way more memory-hungry hardware needs. Now, this is where it gets really interesting. When you ask an AI a question, it's basically a two-step process. The first part, the pre-fill phase, is all about processing your prompt. That takes a lot of raw compute power. But it's the second step, the decode phase, where the AI actually generates the response, word by word. That's almost entirely bottlenecked by memory. The processor is just sitting there waiting for data. And that data has to be delivered at incredible speeds. So what's the technical reason for this memory jam? Well, it's something called the KV cache. The easiest way to think about this is that it's the AI's short-term memory, just for your conversation. So as you have a longer, more complex chat, or as a data center tries to serve thousands of users at once, this KV cache just balloons in size, consuming massive amounts of the fastest DRAM money can buy. And it's not just about that active short-term memory. See, to stop AIs from just, making things up, they now use a technique called retrieval augmented generation. This open book test analogy is just perfect. Before it answers you, the AI quickly looks up the facts in a huge digital library. Well, that library has to be stored right next to the processor on super fast enterprise SSDs, and that's driving a whole other wave of demand for flash storage. Okay, so we've got this absolutely explosive demand story. That's one half of the equation, but what makes a truly generational investment is when that incredible demand slams right into a wall on the supply side. And that is exactly what's happening. The industry is hitting a hard physical limit that we call the memory wall. This leads to the obvious question, right? If demand is through the roof, why don't they just make more? Why can't the manufacturers just flip a switch and ramp up production? Well, the answer isn't about a lack of investment, it's about the laws of physics. It really comes down to three core bottlenecks. First, you literally run out of physical space to attach these memory stacks around the GPU. Second, stacking all that memory vertically generates a ton of heat, which is a huge problem. And third, and this is a big one, the manufacturing process itself is just incredibly difficult and resource-intensive. And this right here, this illustrates that third point perfectly. To produce a single gigabyte of this high-performance HBM, you are consuming roughly 3 times the raw silicon wafer capacity as standard computer memory. That puts a massive strain on the entire global supply chain, and it's a key reason why supply simply cannot keep up with demand. So, we've established the dynamic. Massive demand, constrained supply. That's the setup. Now, how do we position your portfolio to benefit? The first and most direct approach is to invest in the companies that actually manufacture this critical memory. Now, what's great about this market is that it's basically an oligopoly. It is dominated by just 3 companies. As you can see, SK Hynix is the current leader, followed by the giant Samsung, with Micron as a very strong number 3. This kind of concentrated market is fantastic for pricing power. So let's quickly run through the bull case for each of them. SK Hynix, they're the leader, they're NVIDIA's main partner, and they are completely sold out through 2026. Samsung, the biggest memory maker in the world, is staging a huge comeback for the next generation of HBM and plans to expand capacity by 50%. And Micron, the only major US player, also has its entire 2026 production completely sold out already. Demand is just off the charts. Okay, that's the direct way to play this. But there's a second strategy that we are just as excited about. It's the classic picks and shovels approach. Instead of betting on one miner to find gold, you invest in the companies arming the entire gold rush. The logic here is incredibly simple and, frankly, very powerful. To try and meet all this demand, Samsung, Hynix, and Micron are spending hundreds of billions of dollars on new factories and new equipment. By owning the equipment suppliers, we benefit from this enormous spending cycle, no matter who wins a few points of market share here or there. And here are our top picks in that space. You've got Lam Research, supplying essential etching tools. You have ASML, which holds a near monopoly on the machines needed to make these advanced chips. Applied Materials gives you that really broad exposure across the whole process. And because building this memory is so complex, KLA's process control equipment becomes absolutely critical for getting usable chips off the line. So let's bring it all home. The single most important takeaway is this. Memory is not just another component. It is the foundational, the enabling layer of the entire AI revolution. The performance of every NVIDIA chip, the capability of every AI model, the profitability of every single data center, it all comes down to the supply of advanced memory. Look, this isn't just another tech trend. We see this as a fundamental, multi-year shift that's reshaping the entire semiconductor landscape. The AI revolution will, without a doubt, be built on a mountain of memory. So the only question you should be asking yourselves is this: is your portfolio positioned to capitalize on it?